Hi guys, welcome back to the channel. So today we are going to be looking at the lead code question, which is continuous array. So in this particular question we have a nums which will contain all the binary integers which are present in the nums. So it can be either 0 or it can be 1, and then the range of length is going to be 1 to 10 power 5. That means we need to solve this in big O of n or big O of n log n, so that we can it will be accepted. So we are given an array, and then we need to find the maximum length of the continuous subarray such that we have equal number of zeros and then equal number of ones. So let us see the solution in terms of brute force approach. So if we solve by a brute force, we need to pick a array and then it should be continuous. That means we should pick the starting point, start point, and then again we are going to pick the endpoint, which is going to be j, and then for starting point it is going to be I, and then again we need to travel one more for from I to j to see whether it is to count the number of ones and then zeros, and then if count of 0 double equal to count of 1, then we can say that this will be the length of the array, and then we are going to say answer is going to be maximum of answer and then j minus I plus 1. So this will be our brute force approach. Why? Because we are picking the starting index and then we are picking the ending index, and then from the range we are taking from I to j, and then we are counting the number of zeros and then number of ones. If it matches, then we can say that this is the particular uh, array which we want, and then we can keep the global variable which is answer. It is going to keep whether this particular array is the maximum length we can get. So we'll be taking that, and then for this, if we see the time complexity, it is going to be big O of n cube. So this is going to be big O of n cube. So we need to optimize this solution. So how can we make it better? Suppose let's say we are given that it contains zeros and then ones. So whenever we want zeros and then ones, we can remove this particular loop, and then we can store prefix 0 and prefix 1, and then whenever we want from I to j, then we are going to say the prefix of prefix 0 of j minus prefix 0 of I minus 1 should be equal to prefix 1 of j and then prefix 1 of I minus 1. So whenever we match with this particular case, then we are going to say that this will be the array which we want. So we had reduced this big O of n cube to big O of n square, and then can we optimize it better way? This is going to store the number of ones and then zeros at this particular index. Suppose let's say I am given like 0 0 and then 1 and then 1 and then 1 and then 1. Now the prefix 0 is going to be like, it is going to store the number of zeros. So that means it is going to be 1 1 and then 2 and then 2 2 2 2 and then 2, and then 1 is going to be 0 0 0. This is going to be 1 and then 1 and then 2 3 and then 4. So at one particular index we are going to store the number of zeros and then number of ones. So this is for prefix 1. This is going to store the prefix 1, and then the above is going to store the prefix 0. And then from this we are going to say the number of zeros, and then will be dependent upon this. Suppose let's say we want to calculate the number of ones from here, then we are going to consider 4, and then whenever we minus with the previous index which is I minus 1, then we are going to get the number of ones which are present here. And then we are, if we want the number of zeros between these two arrays, then we are going to say 2 minus 2, which is going to be 0. So we are going to get the number of zeros from this. And then how can we make it better way? This is going to be big O of n square. So this is the time complexity. And then can we do it in a better way? Suppose instead of storing prefix 1 and then prefix 0 again and again, can we use only one variable such that it will store the number of zeros and then ones? Yeah, we can store that. That is, let's take count as initially 0, and then whenever we meet 0, we are going to minus the count, and then whenever we meet 1, then we are going to plus the count. So for this it is going to be minus 1, and then again minus 2, and then minus 1, and then 0, and then 1, and then 2. So this is the case for whenever we are considering count as only one variable, and then we are going to store, if it is 0, then we are going to say that we are going to minus the count, and then whenever we meet with the 1, we are going to plus the count. So how can we get the number of zeros and then ones from this particular count? Let's say suppose we are right here. Suppose I am right here, and then I want to know the number of zeros and then number of ones. And then I need to make sure that number of zeros and then number of ones will be same. That means whenever I meet 2, then whenever I meet 0, then there must exist a 0, such that if I remove this particular 0, then the number of zeros and then ones are matched. This is match. Why? Because the number of extra ones or zeros should be removed from the prefix of previous one. Suppose let me consider this particular case. So if I consider this particular case, where I have 0 0 and then again 1 and then again 1 and then 1 and then 1. Now I need to get the number of the maximum length of a subarray such that the same zeros are present and then same ones are present. If I consider this 0, then I need minus 1. So whenever I remove minus 1 from the prefix, I'll get the same zeros and then same one. Let us consider this one. I don't have minus 2, and then if I come back here, this doesn't have any minus. We have minus 1, so this is going to be minus 1. So if I remove this particular array from this array, then I am going to get 0 1, which is going to have same number of zeros and then same number of ones. So whenever we have same count in the previous time, we are going to remove that, and then whatever the length which is present, we are going to calculate that as answer. Suppose if I move to here, then here I am going to have 0. So I can get the same number of zeros as ones from here as well. And then when I move to here and then again 2 and then again 1 and then again 0. Let me consider this particular 0. Here I'll have 0. So now if I consider this particular array, we have same number of zeros and then ones. That means this is the array which is maximum length we can get from this particular index as the ending. So it can be 0 is present here as well, and then 0 is present from here as well. Why? If I consider this particular array, it is going to have same number of ones and then same number of zeros. And then if I consider this particular array, it is going to have same number of ones and same number of zeros. So I should not consider whichever the near. It should be far, like it should have the index very least. So whenever I meet this particular index, I am not going to store this particular index. So whenever we want to store the count, we are going to store the count in terms of indexes. Suppose if I want to store the count of index, if I want to store the index of this particular count, I'll not be storing. Why? Because it will be present here itself. So here I am going to write the count will be 0 and then index will be -1. So this I am going to store, but whenever I come here, I am not going to store this particular case. Why? Because I want to get the maximum length which I want from the array. And then whenever I meet with 1, I'll store this particular index, not this one and then not this one. Why? Because I need the maximum length. So if I consider 1 between this one and then this one, this is what I am going to get as array. Suppose if I consider from here to here, then I am going to get this particular array, which is going to have 2 ones and then 2 zeros. That means whenever I meet first time count, I am going to store its particular index, and then whenever I meet again same count, I'll not be storing the same count. I'll just be calculating the maximum length I can get from this particular array. So let's go through the code. And then for this, I'm going to take the map. This is going to store the count as the key and then value as my particular index where I met this particular count. So for this 0, it is going to have the index as -1, and then I am going to traverse from 0 to size, and then whenever I meet with the nums of I equal to 1, I am just incrementing the count, and then whenever it is 0, then I am decrementing the count. And then whenever I found this particular count previously, that means there is already a count which is already present previously. So if I remove the particular array from that particular, this is what we are doing. Suppose if I meet here, if I have this particular 0, then I am going to say what is the index of this particular count. It is going to be -1. So I am going to consider this particular array as my answer. So I'm going to calculate answer equal to maximum of answer and then I minus mp dot count. This will be the index. So we are not taking this particular element, we are considering from the next element. So I am writing as I minus mp dot count, not I minus mp dot count plus 1. And then whenever I meet the count for the first time, then I am going to insert it into the index, and then at last I am going to return the answer. For this particular solution, the time complexity is going to be big of n, and then the space complexity is going to be big of n. Why? Because we are considering extra map to store the indexes for the particular count. Yeah, that's all for this video. Thanks for watching.